This is Ralph Sass, and this is the lecture for Managerial Accounting, Chapter 10. It'll be in two parts, each one about 15 to 20 minutes in length. Chapter 10 deals with standard costs and variances, and the big thing is the variances and how we go ahead and calculate those. Standard costs are benchmarks. They are what we would expect when we're measuring performance. There are two things we're going to look for. We're going to look for price standards and quantity standards. And if you think about it, if we're running a manufacturing plant or something like that, we're going to have price standards for how much we should spend per square foot or linear foot of wood or what have you, and then a quantity standard for how much wood it should take to build a particular item, perhaps a kitchen table. So if you think about it, if we're building an oak table for an oak kitchen table, it should use X amount of wood, i.e. that would be our quantity standard, and that wood should cost us X amount of dollars per square foot, per linear foot, what have you, and that would be our price standard. The standard we're going to use is the standard price we're going to use is the final delivered price for the materials net of any discounts. So it's going to be the kind of the price we paid, including things like sales tax and things like that. And the standard quantity per unit is going to be the amount that we purchased. Usually, there's going to be one exception when we purchase and use different amounts. But that quantity per unit is going to be summarized someplace on some bill of materials, and it may be done by engineering standards, what have you. When we're looking at direct labor, quick note, and I'm going to backspace here, sorry. This is for direct materials, okay? We're also going to have standards for direct labor, and the standard rate per hour is a single rate usually, and it's going to reflect the wages. So if we have one individual making $10 an hour and another individual working earning $20 an hour, that standard rate would probably be the average of those two, which would be $15 per hour. And then we're also going to have a standard hours for the manufacturing of that particular product. And notice what we do there is we use time and motion studies for labor operations. I had a friend when I was in Wisconsin that worked for a life insurance company, and I asked him what he was doing, and he said he was watching people process claims and applications and what have you for life insurance and health insurance, whatever, with a stopwatch. What was he doing? He was trying to come up with how many hours, i.e. minutes, does it take to review a death claim, or how long does it take to review an insurance application to decide if you wanted to provide that company with insurance. So we're going to have, for direct labor, we're going to have a standard rate and some sort of standard hours or units. We can also do the same thing for manufacturing overhead. Notice we're going all the way kind of back to chapter 2 in the text, where we talked about direct materials, direct labor, and manufacturing overhead. The same applies to manufacturing overhead. We're going to have a price standard, which is going to be how much, what the rate is for a particular item. And then we're going to have a quantity standard for how many hours or how much of that base we should use. Keep in mind, a lot of times it was machine hours or the more common labor hours. Now, what we're going to have is we're going to have some sort of a standard cost. They have here a card, obviously. In today's day and age, it's all going to be on the computer. But notice what they have. They have the inputs, direct materials, direct labor, and manufacturing overhead. They have the standard quantity of hours, how many pounds of materials it should take, this particular item, how many labor hours it should take, and then how many variable manufacturing overhead, and once again, it's 2.5 hours, probably labor hours. They multiplied it by the standard rate, and they got the standard cost, and they said the standard cost was $54.50. And that's all well and good, but if you think about it, if it cost $52, there are 6 items that went into this. 3 for the quantity and 3 for the price. What led it to be $52 instead of the $54.50? And likewise, if we went over and it cost us $60 to produce that unit, which of those particular inputs and which of the particular standards hours or price did we exceed? So it's important that we break this out for direct materials, direct labor, and manufacturing overhead. Now, standard costs were what we used for direct materials, direct labor. It can be used to compute activity and spending variances. Okay, and activity variances we calculated in the last chapter. So what we're going to calculate here in chapter 10 are the spending variances. Okay, and what we're going to do is we're going to take those spending variances and we're going to break them down into price variances and quantity variances. A price variance is going to be the difference between the actual price and the standard price. So what we're looking for in the price variance is how much did we actually pay? What was the cost of that wood for that table, to use my example from earlier? And what was the standard price? What did we expect that price to be? And then the quantity variance is going to be the difference between the actual quantity, in the case of the wood, once again, for that kitchen table. How much wood did we actually use versus how much did we really use? Keep in mind, I may have gotten a great deal on some wood and it was really cheap. Okay, so the price variance would be positive, but it may have had a lot of knots, a lot of bad spots, a lot of warping, whatever, and I had to cut all those pieces out. So the quantity variance may be poor. So we're going to break these variances down into two parts. And the reason why we're going to do this is we're going to separate the price and the quantity variance because different people are probably responsible. Most big companies have a purchasing manager whose sole goal is to buy the items, and we're going to hold him or her responsible for the price variance. Likewise, there are individuals that are on the shop floor that are actually managing the operations, what have you, that particular manufacturing company, and we are going to hold them responsible for quantity variances. Hey, you should have used 10 linear feet. You actually used 15 linear feet. Why is there a difference? Notice, and your book makes the distinction, and I understand the distinction, but I always think about it as price variance and quantity variance. Notice the different terminology they use. It's a materials price variance and a labor and a variable overhead rate variance. To my way of thinking, they're all price variances. I expected to spend X, I really spent Y. So yes, officially is it a labor rate variance? Yes, but it's a price variance. I paid more than I should. And notice likewise on the quantity side, they have a materials quantity variance and then labor and variable overhead efficiency variances. Once again, to my way of thinking, they're all quantity variances, but I do understand, efficiency is how efficient they used it. But once again, I prefer to think of them just as either price variance or quantity variance. Is it the dollar amount spent, or did we use a different amount? I prefer to use this model. This model is on one of the pages of the text, and I prefer to use this because it becomes very apparent whether the variance is favorable or unfavorable. Later on in this lecture, I'll show you the mathematical way. I'm not really fond of that, and when we get to that, I will explain why. Starting off, and I'm going to start off on the far right, which is under item number 3. Under item 3, I put standard quantity, standard price. Okay, and so under the far right, I put standard quantity, standard price. Then on the far left, and I know I'm skipping over 2, but I'll come back to that. On the far left, which is item 1, I put the actual quantity and the actual price. That is the total spending variance. Okay, how much should have I spent, i.e. item 3, versus how much did I actually spend, item 1. And then notice what they put in the middle. In the middle, they put the actual quantity and the standard price. Okay, and notice, because 1 and 2 both have actual quantity, but 1 has the actual price and 2 has the standard price, that the difference between item 1 and item 2 will give us the price variance. And notice also that between 2 and 3, we have the actual quantity and the standard quantity, and then we have under item 2 the standard price, and standard price is also under item 3. So that will give us the quantity variance. So the difference between 2 and 3 is the quantity variance. The difference between 1 and 2 is the price variance. And the overall difference, if you want to think about it, the difference between item 1 on the left and item 3 on the right is the total spending variance, which is the difference between what we spent and what we thought we should have spent. What we spent was item 1, and what we thought we should have spent based upon standard quantities and standard prices is way over there in column 3. The actual quantity is the quantity of direct materials that is actually used. That's going to become important in a little bit. The standard quantity is the quantity that's allowed, how much we should have used. And the actual price is the actual amount paid, including shipping and all those good things. And it's the net price. So if we get a discount, it's going to be net of that. And then the standard price is the amount that should have been paid. Okay, what's the price we thought we should have paid for that particular item? So notice what we have here, and this is a materials variance example. They have the following direct material standard for fill in their parka. It should use 1.1 kilogram of fiber fill per parka at $5 per kilogram. Last month, they used 210 kilograms to fill 2,000 parkas, and the total material cost was $1,029. Now I'm going to flip back and forth between these next two slides here for a second, I believe. Notice the 1,029. That actual quantity, actual price, all I had to do is take that material cost was 1,029, and that is the number that's going to be in that far left-hand column. Now in the far right-hand column, I want the standard quantity and the standard price. And to do that, I need to come back here and say we made 2,000 parkas. Each one of them used 0.1 kilogram, and the cost should have been $5 per kilogram. So for my standard, I'm going to take that 0.1 times 2,000, and that'll give me 200, and multiply it times $5 per kilogram, and that's $1,000. Now the first thing to note is the difference between the column on the far left and the far right is $29. So the difference between the standard quantity, standard price of $1,000 and the actual quantity, actual price on the left-hand side of $1,029 tells me that my overall variance was $29. Now notice what I put in the center. I put the actual quantity used. The actual quantity used in this case was 210 kilograms. Okay, so I'm going to put that 210 there in the middle. And notice I'm going to multiply it by $5 per kilogram, and that'll give me 1,050. And so notice my quantity variance is $50 unfavorable. I spent more than my standard. Okay, and what that's telling me is I used more than I should have. So now I'm going to go down to the production floor and say, okay guys, why are we putting more, or why are we wasting some of this fill? And maybe it's poor training or bad equipment, or maybe it's bad fill. Maybe we had to throw some out because it got damaged, wet in transport. But then notice the difference between the far left column, the actual quantity and actual price, and actual quantity standard price. That one is a $21, and it's favorable. To buy that quantity, I should have spent $1,050. I only spent $1,029, so it's $21 favorable. So I got the material cheaper than I would have expected. Now, one quick note, and I'm going to go back to that earlier slide. No place here told us that the actual price paid was $4.90. But if you take a look at this, the question then is okay, on the far left, how did they figure out that $4.90 per kilogram? They took 1,029 and divided it by the 210 kilograms the actual quantity they used, and that gave them the $4.90 per kilogram. So that's how they were able to calculate that amount. So there's the 2,000, and there's the 1,029 divided by 210. Now, this is the way you can put this down on a note card or what have you for exam purposes. I do not like using these equations. And the reason why, the materials price variance. We figured out on this prior slide, the material price variance on the left there is $21 favorable. Notice we take 210 kilograms, and I'm going to the bottom there, multiplying it by a negative 10 cents because we spent $4.90 minus $5. So when you multiply 210 times negative 10, it's negative $21. I have a hard time imagining that negative $21 is favorable. To me, a negative $21 is unfavorable. Now, I understand what that's telling me is I spent less than I should have. So I understand what it's telling me. I just struggle with the sign. And I struggle with the sign also on the material quantity variance. Notice $5, I'm skipping all the way to the bottom there, $5 per kilogram times I used an extra 10 kilograms is $50. Well, a $50 positive is a positive number. To me, that's a good thing. It should be favorable, but notice it's unfavorable. So the problem I have with using these formulas is the sign. I don't like the sign. I think the sign misguides me. So because of that, my preferable way to set up these variances is in this chart here, not in the equations. However you choose to do it is up to you. Just keep in mind, if you do choose to use these equations, negative numbers are favorable, positive numbers are unfavorable, and to me that just seems not very apparent. Now, the reason why we do this is material price variance, as I already mentioned, is usually responsible. It's usually the purchasing manager, what have you, that's responsible. And the materials quantity variance, it's usually the production manager. To be quite honest, there's usually some finger pointing that goes on here because the production manager goes, well, you bought cheap stuff, and that's why I had to use more. And then I thought, and if you would have spent additional money on higher quality products, then I wouldn't have used as much. But it gives us a spot to look for ways to improve our operation. And that's really the purpose of variances. The purpose of variances is not to point out blame so much as to, and frequently they are in the real world, but the reason why we want to find these variances is so it finds ways so that we can improve our operation. Okay, and once again, this is just going through the fact that, you know, they purchase cheap material, and that's why. And notice the purchasing manager, I love that. Your poor scheduling requires me to rush order materials because I have to rush them. It's going to cost me more in shipping, and if you'd have better production plans, what have you, you know, I could buy the equipment or the product cheaper. Once again, does somebody then have to step in and determine where these issues are? And the answer is yes. Okay, so here's a quick example. Last week they used 1,700 pounds to make 1,000 zippies. Quick note, a zippy is supposed to take, you notice there in red, 1.5 pounds. So they produced zippies, 1,000 zippies, so they should have used 1,500 pounds of material. They actually used 1,700. Total material cost was $6,630. So the question is how many pounds of material should they use to have made 1,000 zippies? Well, I already gave that kind of away here. 1.5 pounds. They produced 1,000 zippies, so it's obviously 1,500. So the standard in that case would have been 1,500 pounds of material. Their material quantity variance for the week. Okay, now here they're going to figure it out using the formula, and that's fine. Notice they've got $4. They should have used 1,500 pounds. They actually used 1,700 pounds, so they used 200 pounds more than they should have. And I'm going to skip back here, sorry. They used 200 pounds more than they should have, and each of those pounds was at $4. So we're going to take the 200 pounds times $4, and it's $800 unfavorable. Once again, my preference is to use the left hand, right hand, center, but if you want to use the equation, you can. Notice they took the equation and they took the standard price and they took the actual quantity minus the standard quantity. That's how you go ahead and read that formula. Their material price variance for the week. Okay, and this also gives a good example. Notice there's 170 favorable and unfavorable, 800 favorable and unfavorable. And most of the multiple choice questions you're going to find on the quiz are going to do something like that. And it's important to know not only the direction, favorable or unfavorable, but whether it's a price variance or the quantity variance. And once again, they're using the formula. I would have used the left-hand, right-hand type side. Notice they took the actual quantity and multiplied it by the difference between the actual and the standard price. And they got the difference between the $3.90 and the $4 was a $170 favorable variance. And this is the way I would have set it up. Notice they put the entire 6,630 on the far left. They put the standard price and the standard quantity for the 6,000 on the far right. And then they put the actual quantity up, material they used of 1,700 and the $4 per pound in the center. That is the way I would have preferred to do it, but really it's up to you. I'm going to stop there and finish this up on the next video.